Hey you, Mr. Fritz, come here. I think you have to make a video.
Me?
Yeah, come on.
Oh, I didn't see you there. Hi. Let's talk about sine regressions and applications. Here I have a modeling data example. We've got a table of values. We are talking about a mean monthly maximum temperature in Celsius for a city in Greece. So here we have this beautiful table here. We've got months, we've got temperature, all kinds of good stuff. What we want to do is we want to create a sine function in the form of t is approximately equal to a times the sine of b times the quantity t minus c plus d. And we want to use it to model the data. So we need to figure out some good estimates for these constants a, b, c, and d without using technology, aka by hand. So we're going to use January is equal to 1, February is equal to 2, and so on and so forth. We're going to do that first, and then we're going to actually use technology, aka a calculator, to check our answer. And then we'll see how well our model actually fits. So let's dive into this. I have a grid for us, and I want to first plot all of this data. So what I'm going to do here is on my y-axis, this is going to be my temp, and my x-axis is going to be my month. And my months will go in order. 1 is January, 2 is February, 3. And for my temperatures, let's see, I have a peak of 27. So let's take this thing up to 30. And I think I can go by 2s. So I'm going to label this by 2s. Okay, now that I have my graph ready to go, we're going to plot all these points. I'm going to put this in red. So I'm just going to take each of these values and plot it over 2 periods. So basically I'm just going to take this 1 full year and plot it twice to get kind of 2 periods of this data plotted. Okay, so that took a little bit of time, but now we have all of my data plotted, and we can kind of see the sinusoidal pattern to this. So actually, I am going to jump to something a little bit cleaner, and I've plotted this in Desmos, and this is kind of what my graph looks like. Hopefully yours looks something like this. And so what I can do is I can actually sketch in kind of a rough idea of what the sine curve should look like. And it's not perfect, but it's a rough estimate. Already I'm seeing kind of some smooth fluidity to the sinusoidal nature where it's going up, it's going down, just like I would expect a sine curve. So what I want to do next is trying to make this by hand equation is I have to figure out what my A, my B, my C, and my D is. So in order to do that, we're going to have to look at the properties that impact those constants. So to start off, for the A value, I need to look what my amplitude is. So in order to do that, I'm going to kind of like take stock of what my highest part of this graph is and what my lowest part of this graph is. And basically this is 2 times my amplitude from my min to my max. So if I figure out what this range is, then A will just be half of that. So what is that, about 13? So if I cut that in half, that's about 6.5. So that means that my amplitude is 6.5, so my A value is 6.5. Now I should be specific here and say my A value is only positive 6.5 if I choose a starting point in the middle of my graph, which I will. So I could just as easily make this a negative 6.5 if I were starting and going down rather than going up. But I'm going to keep things like the normal sine curve as much as I can. So my A is equal to 6.5 because the amplitude equals 6.5. All right, let's actually jump over to the D value because I think that one's a little bit easier to get next. So in order to do that, I'm going to kind of eyeball about halfway in between my max and my min. Actually, I can calculate what this is. If I said that 27 is my max and my min is 14, I can go ahead and take the average of those two. 27 plus 14, divide that by 2. That makes my midline, or the middle of this sine curve, to be 20.5. So let's sketch that in about here. So the midline is y equals 20.5, and so that means my d is going to equal 20.5. All right, now let's talk a little bit about period and the phase shift. The period, actually, believe it or not, is a little bit simpler than it might seem, because we know that this data models a 12-month interval. So really, the time that it takes between where I start my wave and when it starts to repeat itself, that should be one period, which in this case is 12 months. So the b is equal to my period, or rather 2 pi divided by my period. So that's going to mean that b is going to equal 2 pi over 12 or pi over 6. So that's my b value. And then finally, c is my phase shift. Well, if I say that I'm going to start my wave, if I say that this is where I'm starting, then my phase shift is going to be how I got over to that point. So it looks like that is going to be at approximately the 5th month. So that means that my c value will be 5 since I had a phase shift of 5 to the right. So if I put all that together in that form of my original, t for temp is going to equal, let's see what the format that it was asking for me. T equals a sine b t minus c. So t, capital T, is going to equal 6.5 times the sine of b, which is pi over 6, times t minus 5, plus, and running out of room, let's see if I can scoot that over, plus 20.5. So that's my by hand equation. This is pretty good. Hopefully I could graph this to check how well I did, but we're actually going to use our graphing calculators to come up with the sine regression based upon the data, or based upon the calculator's calculation, and we'll see how closely it matches this.